Hi, my name is Madi and this is my Physics 2211 Lab 4 Oscillations. The first goal of this experiment is to compare the predicted motion with the observed motion of a mass on a spring. The second goal is to plot the change in energies of the mass spring Earth system through time. The findings show similar positions between the predicted motion and observed motion over time, with a few deviations, and the total change in energies of the system is also zero throughout the observed time interval. A key concept of this lab is Newton's second law, which states that the net force acting on an object is the change in momentum divided by the change in time. This equation is related to the velocity update formula, and the position update formula is related to the velocity update formula as shown on the slide. The energy principle states that the total change in energy in the system equals the work done by the surroundings on the system and the transfer of thermal energy to the system from the surroundings. And the energy principle as a system must be defined as the impacts what energies are involved in a system with multiple interacting objects, which can have kinetic energies and potential energies, which are shown below, as well as the thermal energy shown in the mathematical equations present in this lab. In this lab, the system is the Earth spring and the mass. The surroundings are nothing that does work on the system, therefore the change in energy equals zero because the system has multiple objects. Potential energies are considered, therefore the total energy of the system equals the sum of kinetic gravitational potential energy and spring potential energy. The free body diagram of the system at static equilibrium shows the forces acting on the system, including the spring force and gravitational force. The tracker analysis of the oscillating motion of the mass on the spring, the position of the mass in the X and Y tracked and stored in a table that was then placed in an Excel file and converted to a CSV file for model analysis. The tracker analysis shows that the mass of the object is 0.4 kilograms and that there is 0.09 seconds per frame, the change in time in the object's initial position. These are the initial conditions for the computational model, which are derived from the initial conditions presented in tracker on the previous slide. Here are the interaction constants of the model. We are told that the spring constant K and the relaxed length 10 for the spring can be found in a pre-lecture video, so the values in the code are from that video. However, the equations and steps to calculate the spring constant and the relaxed length are shown at the bottom of the slide because we can see that the spring constant can be determined from the oscillation period that we recorded through tracker. This is the iteration step for the computational model. We can see that the change in energies for the energies involved are converted from mathematical equations to code, and we can also note that the code for the comparing the tracker analysis within the model is also included. There are some important equations derived from the model, including the distance from relaxed length, the energies involved in the net force, and the update formulas in mathematical equations and their coded equivalents are shown in this iteration step as well. These are the graphical results for the computational model. The graph on the left is the changing energies over time. The two graphs on the right are the position versus time graphs for the model and the observed tracker data for the X and Y positions of the object. In the change in energy graph, the potential energy oscillates and is opposite sign to each other. The kinetic energy also oscillates in the position graphs and the Y position between the observed data and model differ more than the X positions between the two data, though both show some differences between the observed data and predicted data. Some potential sources of error include not accounting for other forces, which is account for the discrepancy in the X and Y position versus the discrepancy now accounting for other energies and not consistently marking the center of mass during tracker analysis could also cause problems. Looking at the change in energy versus time graph, the sum of the change in the kinetic energy versus the change in gravitational potential energy and the change in spring potential energy equals zero. This sum is the change in total energy of the system, which is denoted by the orange line. This sum shows that nothing in the surroundings does work on the system, which is true based on the definition of the system in this experiment. By measuring the time difference between troughs and the X and Y position data graph and the Y position data graph and finding the average period and the average oscillation period. For the X position and Y position can be determined from the average oscillation period, and the X position data is 1.66 seconds while the oscillation period and the Y position data is 1.5 seconds. This difference in oscillation period has a major impact on the calculation for the spring constant K and the calculation of the spring force and the calculation of the spring potential energy too. This difference can be caused by numerous factors, including drag forces that we didn't account for or errors made during tracker analysis, like not properly tracking the center of mass. Thank you.